Now we're getting into a new concept called phase shift. And previously, if we talked about phase shift, it was just to say that there was no phase shift. Okay? I would draw you a graph, something like this, and we'd have a sine function on it, for example. And it would always start at the origin, right? You'd always have the beginning of the sine graph right there. And the beginning of the sine graph is where the phase shift is. So if the phase shift is on the origin or on the y-axis, then the phase shift is 0. But what we're doing now is we're saying, hey, that's not going to be the case anymore. Let's try a new xy coordinate, something like this. And you see that the phase shift, the starting point of the parent function trig graph, is no longer on the y-axis. That means we have a non-zero phase shift. So this value right here, you can think of this as h, and that is the phase shift. Okay, so the way that turns up in an equation is you get something like this. We've written this general form of our equation before. You have the amplitude, A, you have a sine function, and then you have our horizontal scaling factor, B, then you have, in parentheses, x minus h right there. We haven't really dealt with that h until now. Now it's time to deal with non-zero h's. And you can see, if you look at this table here, we've got a bunch of non-zero h's. So let's work through what these mean. And a lot of these things are not going to change from what we saw before, like midline amplitude. They don't care what the phase shift is, so we can just do these like before. Y equals -3. Okay? Amplitude on this one, 4. Remember, we do the absolute value of the multiplier that's in front of cosine. We don't worry about the vertical reflection when we talk about the amplitude, because a wave that goes 4 units up will also go 4 units down. It's just in terms of its bigness that we talk about amplitude. Now, in terms of period, let me clear some room here. Come on. Let's talk about the period of this function. Remember where period comes from. That comes from this little guy right here, which is b. So for this equation that I'm working on, this guy right here, I would say b equals 3, and p, the period, equals 2 pi divided by b. Okay, so that just becomes 2 pi over 3. Okay, so we put that right here. And now we get to the phase shift, which is the first time we're seeing something that's not a phase shift to 0. But it's really easy. You just look at this number right here. Okay, there it is. That's the phase shift. Remember, phase shift is always in the terms of b times x minus h. So whatever that value is that's being subtracted, that's your phase shift. So this is 5 pi minus 4. And you might be noticing this negative sign here, right? It looked like a minus 5 pi over 4, and it turned into a plus 5 pi over here. You can think of that as in, the horizontal shifts left and right. Remember, negative went right, positive went left. It's sort of like that with the sign flip. Okay, so that's the first example of this. I want to go through one more example, and then I think you'll get the idea. Let's do this last one on the list right here, because that looks different. And there's a couple different things about it. We'll get into those. For the first thing you should notice is that this equation at the very bottom here, this function, is not in factored form. It's not in general form, because I don't have it written as b times a parentheses. And what that's doing is it's obscuring the effect of the horizontal scaling factor. It's mixing it in together with the phase shift. The phase shift for this one is not -2 pi over 5. First, before we can say what the phase shift is, we have to factor out this b right here, that horizontal scaling factor. So let's go ahead and try that. I'm going to write this down here. We have 4 cosine of 4 pi over 5x plus 2 pi over 5 minus 2. And if you're looking at it like, what do I factor out? What's the b factor? Well, whatever's in front of x, that must be b. Okay, so I can at least start this much. I can say 4 cosine, and I'm just going to factor out that 4 pi over 5. Okay, and then I'm going to have x plus something. I'm not sure what that is yet, but it's going to be x plus something. Okay, so let's take that idea. I'm going to set this over here for a moment, and let's figure out what that something is. Remember how you factor things out. And I'll just give you a simple example. If I have 2x plus 4, and I want to pull out a greatest common factor of 2, what I'm doing is I'm basically saying the inside contents are divided by that greatest common factor, and then I simplify. So this becomes 2 on the outside. We cross out those 2's and get x, and then 4 over 2 equals 2. Okay, that's the process of factoring out a GCF. So let's try it for this one. It's a little bit more complicated. We're going to have to say this is 2 pi over 5, all divided by 4 pi over 5. Okay, see how that works? Now, if I bring this over here, because I think compound fractions are a real pain to deal with, so I like making it easy with an old-fashioned division sign. 2 pi over 5 divided by 4 pi over 5. Well, keep flip change. We're going to turn this into a multiplication problem with 5 over 4 pi. And those 5's cancel out. 2 cancels out, leaving a 2 on the bottom. The pi cancels out. Nothing's really left here. It's just 1/2. Okay, so this becomes 4 cosine 4 pi over 5 x plus 1/2, okay, minus 2. So that is our factored form. And now we're ready to start. That's just what you need to do to start this problem. Because these equations, these functions here, need to be in the factored general form before you can really start to say what's the phase shift. Otherwise, you're going to get messed up. So let's go through it. Midline is easy, right? That's just the subtraction value at the end. Amplitude, it's also 4 in this one. Period. Let's talk about the period for a second. Because I'm looking at this and I see b equals 4 pi over 5. So that means p equals 2 pi over b, right? That's our formula. Which means 2 pi over 1, that's what 2 pi is, divided by 4 pi over 5. Which we're going to do a little more keep flip change here. This becomes 2 pi over 1 times 5 over 4 pi. We've got some cancellations going on, and you just get 5/2 for the period. Okay, so we put that 5/2 in here. And now all that's left is the h, the phase shift, which in this case, fortunately, this one's easy because we did the work already. We factored out that GCF, and we can say that the phase shift on this one is negative 1/2. Don't forget that sign flip. Now, I want to point out one thing before you scoot off to another video. Take a look here. See how the period of this one has a pi in it, and the phase shift has a pi in it? That's normal. It's typically what we see. But in this one, something weird's going on. No pi in these guys. So why is there no pi here? And the reason is related to that GCF. If you take a look right here, see our factor of b had a pi in it, so we factored out a factor of pi. We pulled out the pi from the inside of the parentheses, and that left you with non-pi's over here. Okay, so this one's going to have regular fractions, like integers, 5/2, negative 1/2. It's going to look a little different on the x-axis than what you're used to with a graph. But it's really it's nothing new. There's not a new rule we have to worry about. We just have to cancel out pi's. When you factor out a pi, you cancel them out. Okay?